Welcome back to Kitchen Chemistry.
Today, I'm going to be testing to see the effect that the volume of water in the can has on how much it crushes. So this is can 0, that means 0 tablespoons of water, 1 tablespoon, 3, 5, and 7. Here is my experimental setup. I've got my pot of water, it's all the way full. I checked the temperature, it's the same as last time. I'm going to heat the cans on the stove for 1 minute each. The only thing that I am changing between this experiment and my original experiment is the amount of water. Everything else is going to stay the same. I'm going to start with the highest volume. This one has 7 tablespoons, and I'm going to heat this up for 1 minute. Three, two, one. The can that had 7 tablespoons had absolutely no crushing whatsoever. Let's try 5. So I'm going to put it on. And we'll time it for 1 minute. All right. 5, 4, 3, 2, 1. 5 tablespoons, and again, no crushing at all. Now let's try 3 tablespoons. 3, 2, 1. And again, 3 tablespoons, and there's no crushing. Let's try 1 tablespoon. 2, 1, and success. Just to see what's going on, I decided to add in 1 more can. We're going to do it a half a tablespoon. We're going to see if there's any difference between a half a tablespoon and 1 tablespoon. I need you to pause it. So 2, 1. Last but not least, I'm going to try no water at all and see how that affects it. Cans that we tested tonight. So it's clear that the 0, 3, 5, and 7 didn't crush at all, but it's hard to tell between these two which one crushed more. So what we're going to have to do is come up with a system to calculate crushness, to figure out which one is more crushed and which one is less crushed. So the system that I've come up with to see which can was the most crushed was to compare their volumes before and after the crushing. So the nice thing about these cans is they all have the same volume, right? So I can measure the volume of a can that wasn't crushed at all, and then I can measure the volume of my crushed cans and see how much of that space that was originally there was taken away by the smushing of the can. So I'm going to take a can that wasn't crushed at all. This is my number 7. I'm going to fill it with water. Fill it with water, and then I'm going to find the volume of that. So some of you are like, Michelle, that's a waste of your time because the can has the volume on the side, which is true, but the volume on the side is the volume of the liquid in the can, and it doesn't account for, here we go, it doesn't account for any air that's in the can that isn't taken up by liquid. So this 355 is how much liquid there was, but in reality, there's a little bit more than that. So this is the volume of my can when it's not crushed and has been totally filled with water. So you can see that it's a little bit above, 350, but it's not all the way to 400. So we're gonna guess between 350 and 400, it's about 370, right? Looking at the bottom of my meniscus, I'm gonna say that's about 370 milliliters. Since 0 tablespoons, 3, 5, and 7 all did not crush, we're just going to assume that they all have the same volume of 370 milliliters. Now I'm going to figure out the volume of my 0.5 milliliter can. Ooh, okay, I've got a hole, which means I have to be a little bit careful about this. I did my best. There was a hole, but I had to try to grab it out of there as quickly as I could. And looking at our volume, we are at about, we're more than 100, but less than 50. So I'm going to say we're about 110. We're about 110 milliliters for the 0.5 tablespoon can. So my 1 tablespoon can also had a bit of a leak. So I did my best. And looking at our volume, we're right in between 100 and 150 milliliters. So I'm going to say we're at 125 milliliters for the 1 tablespoon can.
So the way that we have to think about this is the smaller the volume of the can, the more the can was crushed, because the smaller volume of water means that the space that was originally there was taken away by the crushing. So smaller volume equals more crush.